So this is the last section of chapter 10. We're going to expand a binomial with Pascal's triangle. What do I mean by that? We're going to have a binomial. What's a binomial? Anybody? Two terms. Two terms, right? So something like x plus 3, 3x minus 7, x plus y. I want to go with the easiest, just two variables, a plus b, okay? And I want to have a certain power on this binomial. What power should I put on it? Anybody? 2? Let's go for a little bit higher. 4. Okay, 4. A plus b to the 4th. If I were to actually ask you to simplify this, to expand it, it's going to take a long while, right? First thing is to understand that a plus b to the 4th power is this base, a plus b times itself 4 times. And then after that, you have to distribute and combine like terms, and then distribute and then combine like terms, and then distribute and then combine like terms. I'm not going to do all of it, but I just want to give you a little taste of what it looks like, right? You go a times a, that's a squared, a times b, that's positive ab. Then you go b times a, that's positive ba, but you could switch it and make it ab again. And then b times b, that'd be a positive b squared. And then you could combine this positive 1ab with that positive 1ab, and that would be a positive 2ab. Of course, with the a squared in the front and the b squared in the back. Now, all we've done is multiplied this binomial times that binomial, giving us a trinomial. But then you would have to take this trinomial and bring down this ab over here, a plus b over here, and then distribute it right here, getting an a to the 3rd, and then it's just tons and tons of work, right? So I'm not going to do it because it takes too long, okay? You could do it this way, but you're going to run out of time on a test. It's going to take up too much of your paper. What I'm going to do is teach you how to expand this binomial, a plus b to the 4th power, with Pascal's triangle. So before teaching you how to expand it, I want to show you how to create Pascal's triangle. So everybody write down Pascal's triangle, and what we're going to do is we're going to make a triangle of ones, okay? A triangle of ones, 1, 1, 1, just like that. Okay, now, is everybody there? There's going to be a lot of patterns on this section. So start with the triangle of ones, and then we're going to simply add this one plus this one. What's 1 plus 1? It's 2, but I'm going to write the 2 down here on the next row. We're going to create another row down here. So 1 plus 1 is 2. I'm going to write it down here, but in between both of them, right? So here it is, 2 right here. And then you put 1s on the outside again. So your original triangle got bigger. Yay? And then we go back, and all the numbers that are right next to each other, you're going to add them. 1 plus 2 is 3, but you're going to put that 3 down here at the next row. So we're going to put 3 right there. And then 2 plus 1 is 3, but write the 3 right there. And of course, you put 1s on the outside again. So now look how big that triangle is, right? And we could keep going forever and ever and ever. I want to do maybe just one more level or one more row. When I add 1 and 3, I want to get 4. When I add 3 and 3, I want to get 6. And notice how I'm writing them right between, but below on the next row, right? 3 and 3 is 6, but I write it down here. And then 3 and 1 is 4. I'm going to write it right here. And put 1s on the outside again. And how far does this go? However far you need it to go, okay? This is Pascal's triangle, all right? Now, how are we going to use it? Well, anything to the power of 0 equals what? 1. So let's, to the side of your triangle, write down the word power. Like I'm talking about clearly to the side of the triangle. Don't put it too close. Put it over here. Put power. And then right below the word power, put the number 0. Because anything to the power of 0 gives you 1. Okay? Now these numbers on this triangle are going to be the coefficients, well, kind of sort of the coefficients of the terms that we have in the answer. But anyways, the power of 0 gives you 1. So then you go to the power of 1. That will give you these two numbers, 1 and 1. And then you go to the power of 2, and that'll give you this row of numbers, 1, 2, 1. And then you go to the power of 3, and that'll give you this row of numbers, 1, 3, 3, 1. And then you go to the power of 4, and it'll give you this row of numbers, 1, 4, 6, 4, 1. Okay? So I hope you guys got that down in your notes. And now time to show you how to use this. Whoops, that didn't work out that good. Let's make this a little smaller. And let's rewrite the question that we had originally. What was it? A plus b to the fourth power? A plus b to the fourth power. So what we're going to do is look at the power that the binomial has. And you're going to go to that particular power. You're going to go all the way down to 4. And you're going to be using these numbers, 1, 4, 6, 4, 1. Yay? Okay, now how are we going to use these numbers? You're going to put 2 sets of parentheses after each number. I know this sounds really weird, but you're going to love it. You're going to put 2 sets of parentheses after each number. So I'm going to write down the number 1 way over here, 1 with 2 sets of parentheses right after the 1. And then I'm going to put plus the next number 4 with 2 sets of parentheses. And then the next number 6 with 2 sets of parentheses. Then the next number 4 with 2 sets of parentheses. And the last number 1 with 2 sets of parentheses. And then after writing the numbers with the sets of parentheses, now we have to deal with all the different powers on each of the terms. So how do we do this? We originally had the power of 4. So we're going to write that power of 4 on the first parenthesis exponent position. This power of 4 is going to go right here to the first parenthesis exponent position. I'm going to put the 4 right there. So since it's the power of 4, if this is a 4, this has to be a 0. Think of it as if you were to add them, 4 plus 0 is 4. You can't go higher than 4 because that's your max right there, your power of 4. Now, the trick is, as we go from this parentheses to this parentheses, the 4 is going to drop by 1, and the 0 is going to increase by 1. Maybe I'll do the 0 in a different color. I want to go red. Okay. So that blue 4 on the first parenthesis is going to drop to a 3 on the next first parenthesis. And that red 0 on this position is going to increase by 1 to a 1 on this position. And then the blue 3 is going to drop to a 2. So put a blue 2 right there. And then that red 1 is going to go up to a 2. That's right. It's like if you guys have already done this before. And then the blue 2 goes down to a 1. And then the red 2 goes up to a 3. And then that blue 1 goes down to a 0. And then that red 3 goes up to a 4. So they completely changed. There was 4, 0, and over here it switched to 0, 4, right? If it confuses you to go down or go down by 1, up by 1 on each one of these, then just go the first parenthesis, 4, 3, 2, 1, 0, and then put 0, 1, 2, 3, 4. Anyway, what do you think is going to go in this first parenthesis? That's right, A. So you're just going to take that A right there. Whatever that first part of your binomial is, you're going to write it in the first parenthesis on each one. And the second parenthesis on each one is going to have the positive B. Of course, you don't need to put a plus. It's already positive, so just put a B on each of those. And believe it or not, this is our answer. If we were to do a whole page of work distributing and combining and distributing and combining and distributing and combining, this would be our answer. All we need to do is simplify this answer. What do I mean by that? Right here, B to the 0 power, we know that that's 1. That cancels out. And then A to the 4th is simply A to the 4th. And you don't need a 1 in front of it, so that's just A to the 4th. That's the first part of your answer. Okay. Moving on to the second part of our answer, we have the number 4 times A to the 3rd times B to the 1. You don't need B to the 1, so it's just 4A to the 3rd B. 4A to the 3rd B. So let's put plus 4A to the 3rd B. And then the third part of our answer is going to be 6A squared B squared. So plus 6A squared B squared. The fourth part of our answer is going to be 4A. You don't need the power of 1. 4A B to the 3rd. Positive 4A B to the 3rd. And the last part of our answer, scratch out that A to the 0. It's just 1. 1 times 1 is still 1. You don't need to put the 1. It's just going to be a B to the 4th. And believe it or not, that's our answer if we were to expand this binomial times itself 4 times. After doing like half hour of distributed property and combining like terms, this is the answer that you get. So Pascal's triangle is amazing, right? right? It helps you do the work way, way, way faster. Now, obviously, we did a simple binomial a plus b. You could have a letter and a number. You could have numbers and letters, like it could be a 2a minus 5b. It could even be a 2a to the second power, take away 7b to the third power. It's all done the same way, though. You go by your power, expand your triangle to that power, and then use those numbers followed by 2 sets of parentheses after each number, including the 1 over there. And then you plug in the first term into your first parenthesis, the second term into your second parenthesis. Again, once again, the power of 4, you write down that power of 4 on the first parenthesis, and you put a 0 right there, and then the 4 decreases to a 3, the 0 increases to a 1. So you're decreasing the blue ones by 1 as you're increasing the red ones by 1. So this one goes down to 2, this one goes up to 2, this one goes down to 1, this one goes up to 3. This one goes down to 0, this one goes up to 4, and that's how you do it. Anyway, let's do one that's a little more challenging. Let's write down 2x minus 3 to the third. It's actually not that challenging because it's a smaller power. So you guys should have your Pascal's triangle on your notebook. I just typed it up right here. So, obviously, the first power of 0 gives you 1. That's a trick to remembering to start with 0. Anything to the power of 0 is 1. Power of 1 will be these numbers. Power of 2 will be these numbers. Power of 3, this is the power of 3. We're going to use these numbers, 1, 3, 3, 1, followed by 2 parentheses on each. So let's do that. I want to put 1, parenthesis, parenthesis, plus 3, parenthesis, parenthesis, plus 3, parenthesis, parenthesis, plus 1, parenthesis, parenthesis. And of course, the second step would be to take the power of 3 and put it on your first blank parenthesis. Whatever your power is, put it on the first blank parenthesis. In this case, it's a 3. If this would have been a 4, well, obviously you'd have to use these numbers instead of these, but yeah, that you put the 4 on the first parenthesis. And you always start with the second parenthesis having a 0, okay? And you're going to be decreasing the first parenthesis power by 1, increasing the second parenthesis power by 1. As you go here, here, and here, till the 3 and the 0 completely flip, 0 and 3. If adding and subtracting at the same time kind of confuses you, just go for the first parenthesis all the way through. So the 3 on the next one is going to be a 2. The next one's going to be a 1. Wait, did I do this right? And then, yeah, that's right. And then the last one's going to be a 0. And then on the red ones, the 0 goes up to a 1, goes up to a 2, goes up to a 3. What goes in the first parenthesis? 2x. What goes in the second parenthesis? Negative 3. So let's put a 2x and a negative 3 on the first one, or a 2x and a negative 3 on the second one. 2x on the first, negative 3 on the second, 2x on the first, negative 3 on the second. This will be our answer, but we need to simplify it. I like to eliminate the ones that have the power of 0 because that just equals 1. Negative 3 to the power of 0, that equals 1. Cross it out. 2x to the 0 power, that equals 1. Let's not mess up on our rules of exponents here. What is 2x to the third power? Don't say 6x. Don't say 2x to the third. What's the answer? 8x to the third, right? 8x to the third. So the first part of our answer will be 8x to the third. Again, you could distribute the exponent to the 2 and to the x. So 2 to the third is 8. 2 to the x to the third is x to the third. You cannot distribute over here because there's a minus sign. This is why we have to expand it using Pascal's triangle. Anyway, this next term right here, we have 3 times, what is 2x to the second? Of course, you're going to do exponents before multiplying. So what is 2x to the second? 4x squared, right? 4x squared. And let's not forget, we still have the times 3 in the front. And what is negative 3 to the 1 power? It's just negative 3, right? So we still have times negative 3 at the end. So in this second term, we could multiply 3 times negative 3. What is 3 times negative 3? Negative 9. And then you could multiply it by 4. What's negative 9 times 4? Negative 36. And of course, we're talking about x squares. Does everybody understand how I got that second term? Maybe I shouldn't be, writing it that far down. And let's go to the third term now. What could I do on the third term? We have negative 3 squared. Start with exponents. What is negative 3 squared? That's 9, right? Positive 9. And of course, we have 2x to the 1. That's just 2x. So you have 2x times 9, and you have a times positive 3 out here in the front. So what's my answer there going to be? 54x, right? Positive 54 with an x. Now, why 54? Because 3 times 2 is 6. 6 times 9 is 54. What about the x? The x just comes down. So 54x. Last but not least, what's the final term?
Negative 3.
Negative 27. There we go. Why did I do it in black? 27. Okay. So there's your answer. Cool?
Yes.
All right. Now, if I ask this question on a test, obviously, even if I did multiple choice, man, those answers would be super long. And you know that on quizzes, it doesn't give you much space. So to make it less confusing for you on quizzes, I will specifically ask for a certain term. Like I could have said, find the third term of this binomial to the third power. And all you would have to do is type in 54x, third term. Or find the first term, that would be 8x to the third, right? Or what else could I ask you with regards to this section on the test? I could ask you something like this. Write down the row of Pascal's triangle that you would use if you were expanding a binomial to the fifth power. Okay? So what would the numbers that you type in actually be? And you want to type in with spaces between your numbers. So what would your numbers actually be that you're going to type in? Okay, 1, 5, 10, 10, 5, 1. Perfect. You would type that in, you get full credit for that question. That's simple, right? That will be on the test. Again, you have to expand your original Pascal's triangle of 3 ones, and that's power of 0, power of 1, power of 2, power of 3, power of 4. Of course, we need power of 5. So if it's set up like this, all you got to do is there you go. That's kind of close enough. When you go 1 plus 4, you get 5. 4 plus 6, you get 10. 6 plus 4, you get 10. 4 plus 1, you get 5. Write the ones on the outside. This would be the numbers that you use when you're expanding a binomial to the fifth power. Question? So once again, to get to your next row, you simply add your numbers. The 1 and the 4, add them, you get 5. The 4 and the 6, add them, you get 10. 6 and the 4, add them, you get 10. 4 and the 1, add them, you get 5. Put ones on the outside again. If you wanted to go to the next one, 5 plus 1 is 6 right here. 15, 20, 15, 6, and ones on the outside again. You could expand as far as you want, right? Let's try a question that's going to be on the test. I want to pause it right here. Go ahead and write it down. Help each other out. The first thing is to expand your Pascal's triangle far enough to get to the sixth power. So I need to add 1 plus 4 and get 5. 4 plus 6 and get 10. 6 plus 4 and get 10. 4 plus 1 and get 5, and put ones on the outside again. And then, so this is the fifth one. And now for the sixth one, we're going to have 1 plus 5, which is 6. 5 plus 10, which is 15. I hope you guys are seeing what I'm doing. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. So we need a 20 right here. And then 10 plus 5 is 15. 5 plus 1 is 6 with ones on the outside again. So this guy right here is what we need. This is what we need to use. And we know that we have a number followed by 2 parentheses, a number followed by 2 parentheses, and so on and so on. And the question right here, give me 1 second, let me be able to group this. The question was to expand, oh, that didn't even work out. Well, we got the red one. That's all that matters, these numbers right here. We wanted to expand this 2x minus 3 to the 6th power, and they want the fifth term of it. So we have our first term followed by two parentheses, our second term followed by two parentheses, our third term, our fourth term, and our fifth term followed by two parentheses. So I need to focus in just on this guy. So my fifth term will be plus 15, parenthesis, 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 parenthesis. Make sense? Now, we also need to think of what do we do with this power of 6? Well, on the first one, you should have two sets of parentheses, and the 6 goes on the first parenthesis or the second? On the first, right? So let's just focus in on that first parenthesis. So if there's a 6 on the first parenthesis here, a 5 on the first parenthesis, a 4 on the first parenthesis, a 3, a 2 on the first parenthesis. That means that there's a 2 right here on this first parenthesis. Does that make sense?
Yes.
Okay. Now, you could go back and count, it's the second parenthesis had a 0, a 1, a 2, a 3, a 4. So there should be a 4 right here. But it's even easier. You know that the powers have to total up to 6 on all occasions, on all parts. So on the first one that had a 6 and a 0, 6 plus 0 is that total of 6. So right here, obviously 2 plus 4 will give you the total of 6. What goes in the first parenthesis? This first term, 2x. What goes in the second parenthesis? The second term, negative 3. Okay? So let's do the math. 2x to the second power will be 4x squared. Bring down the times 15. And we might as well do negative 3 to the fourth power. So negative 3 times negative 3 is positive 9, times negative 3 is negative 27, times negative 3 is positive 81. Now we are multiplying. Maybe I shouldn't have put that plus sign right there. So you're multiplying by 81, right? Originally it was 2x squared times negative 3, but that negative 3 to the fourth power is 81, and we're still multiplying. So it's all pure multiplication. You have 15 times 4 times x squared times 81. So with the calculator, we are going to multiply 15 times 4 times 81. Final answer is 4,860 with your x squared at the very end. And that's your answer. Now, be very careful on the multiple choice ones. You might have this number but negative. You might have the number without the exponent 2, or maybe just the number without the x squared. So be very careful with that on the test. I think we've covered all angles of Pascal's triangle that you're going to see on the test.